Okay, so here we are. We're going to start a unit on quadratics. So that's polynomial equations with degree 2. And we're just going to start by solving using factoring right now. And then next time we'll solve using other techniques, and then we'll go and do other stuff. Okay, if I were to try to solve this equation by maybe, isolating x and saying x squared plus x equals 6, well, it's like, well, then what do I do? Or, maybe I just try to get x squared by itself, 6 minus x, and then take the square root of both sides. That doesn't work, okay? We can't just solve for x on its own. So, maybe you remember from, an earlier algebra class that when we have higher degrees of x, we can't just directly solve. If there are multiple powers of x in the mix, we're going to have to solve by factoring or by some other technique. What we got to do is we got to factor this thing. We're going to say that, okay, x squared plus x minus 6 is the same as x plus 3 times x minus 2. And then we'll do a little more analysis to figure out what types of x's would make that true. Just from looking at it, it looks to me like negative 3 and positive 2 would be numbers I could plug in and get a product of 0. We'll talk more about that in a second. Okay, so before we go to actually solve these things, we need to talk about what does it actually mean to be a 0 or a solution. So where are the zeros? Where are the zeros? Yeah, they're on the x-axis. Yeah, they're where y equals 0. So I see one here and I see one there. Okay, so they are where y equals 0. Or maybe where f of x equals 0, if that's how we're looking at things. And what does it mean to be a 0? Well, it means that the value of the function is 0, which is basically the same thing I was saying to answer the question where the zeros are. I think maybe the intended answer to that was the x-axis. And if they ask, well, what are you really doing when you're finding the zeros of y equals x squared plus x minus 6? We are finding where x squared plus x minus 6 equals 0. So you're finding solutions to the equation x squared plus x minus 6 equals 0, because we need y equals 0 and y equals x squared plus x minus 6. Therefore, we need to find where x squared plus x minus 6 equals 0. Okay, so it comes down to three real cases for solving quadratics, at least in this unit. We'll go and we'll study this a little more in depth in the second semester, one of these cases. But you could have one like we saw earlier where it intercepted twice. From maybe Algebra 2 or Algebra 1 or something that the graph of a degree 2 polynomial is a parabola. So we could have two real zeros. Okay. You could also have one that was upside down and went through the x-axis twice. You could have just one real zero. And what would that look like? Yeah, well, it's got to be a parabola. So we're talking about within the bounds of this being a parabola, how could it intersect the axis only once? Yeah, it bounces on the axis. Might be a good term. Or there's other. I'm trying to remember. So it's coming down, and at the very bottom is where it hits the x-axis. So it really only hits it once. And then it could just be one like, say x squared plus 5. It could have no real zeros either. Okay, so this one has one real zero. And this is no real zeros. And we'll talk about the no real zeros case quite a bit in the second semester. This will be talking about complex numbers, and that will be something interesting to us. Okay, so how could we solve this if we can't just take the square root or just solve for x or something if we're trying to get, just a number solution? Well, the first step is always going to be set it to 0. Okay, start by setting it equal to 0. Okay, that's going to be the first thing. So I'm going to subtract 14 from both sides. So I'll have x squared, 5x, and negative 14 equal to 0. Okay, the second step will be factor it if you can. I'll tell you right now, all of the ones that we're going to encounter today and on the quiz next time will be factorable. Next time is when we will learn what to do when it's not factorable. And I suspect you already know what to do when it's not factorable. You probably don't like it, but the good news is this year it's not going to seem nearly as bad. Okay, so we can factor this thing, right? Two numbers that multiply to negative 14 and add to positive 5 would be positive 7 and negative 2. And then the third is going to be apply the 0 product property if it is factorable, and then solve from there. But I haven't told you about the 0 product property yet. Okay, the 0 product property. Here's the deal. If you've got two numbers and they multiply and their product is 0, then it must be the case that one of them is 0, right? You're not going to multiply two non-zero numbers together and get 0. That's not possible. So we'll say either A equals 0 or potentially B equals 0. That's a guarantee. That's why we like to factor. So going back to that previous example of, we were at x plus 7 times x minus 2 equals 0. Okay, when I had just a bunch of things added together, I wasn't able to just solve for x. But now when I have two things multiplied together and equaling 0, now I'm ready to go. I can say that, well, if these two things are multiplying together to equal 0, one of them has to be 0. So either x plus 7 equals 0, or maybe x minus 2 equals 0. And then this is something we know how to solve. I'll subtract 7 from both sides over here, and I'll get x equals negative 7. And over here, I'll add 2 to both sides, and I'll get x equals 2. Okay, and those are the solutions to that equation. This is an equation that has more than one solution. Okay, so our purported solutions were positive 2 and negative 7. So what I'm going to do is I'm going to go back over here to the original statement of the equation. And I'm going to check just to see what's happening here. Okay, so x equals 2. So 2 squared is 4, plus 5 times 2 is 10, does equal 14. Okay. So that's good. It does make the equation true. Then we've got x equals negative 7. Okay, I square negative 7 and I get positive 49. But 5 times negative 7 is negative 35. If I take 49 and I subtract 35, I will end up with 14. Okay, so we can see that both of these numbers make that equation true in their own way. So we say that they are both solutions to that equation. Okay, in an ideal world, we already have things factored. Okay, that's not going to be the case for y'all almost universally. It's not going to be already factored when you get it. But if it is factored, it makes it really easy to find the solutions, find the zeros. So I'm going to freeze the screen. If you're watching at home, you would want to pause the video. And y'all do it. I'll come around and check your work. If you're at home, It's going to flash up in a few seconds, and you'll be able to check your work against mine. Okay, here you go. All right, so question was, how do we get x equals 0 on the second one? Well, I think probably the way to go is I'm going to write it like this. So one of the things in the red parentheses has to equal 0 in order for the whole thing to equal 0. So that means that either on the left that x has to equal 0, or on the right that x minus 5 has to equal 0. Okay? And if x equals 0, well then I have 0 times some number minus 5, and that'll always be 0 because I've multiplied by 0. It's kind of a game ender. And then over here, if x minus 5 equals 0, well that's x equals 5. So I would have 5 times 0, and, oh, that's going to be 0. And so that's how I get it. We'll have more like this. All right, and before we go too far, I think I need to remind you about a little bit of factoring. Specifically factoring a degree 2 where the leading coefficient is not 1. All right, I was actually really pleasantly surprised on the test with how well y'all did on this, especially compared to my pre-calc classes last year where this was just a disaster. But, okay, I'm going to say that you multiply the 6 and 5, and we're looking for two numbers that multiply to 30 while adding to positive 17. What is that going to be? 15 and 2. Specifically, positive 15 and positive 2. So what I'm going to do is I'm going to take the 17 and I'm going to split it up into those 15 and 2. So that's 15x plus 2x. And then I'm going to keep the 6x squared and the 5 the same. And now I'm going to group and factor. Okay, so I think what can I take out of these first two? Well, there's a 3 in common to 6 and 15. And there's also going to be an x in common to both of those things. So you think, what do I multiply 3x by to get 6x squared? That's 2x. And what do I multiply 3x by to get 15x? That would be positive 5. Then on the second two, well, there isn't anything in common to 2x and positive 5. So I just factor out a plus 1. And then if you've done it right, you'll see that these are the same and can be factored out of both things I'm adding together. So I'll have 2x plus 5 times 3x plus 1. All right, here, y'all solve by factoring. Y'all do these 4. Okay, I'm going to freeze the screen, and you can just check your work against mine when I unfreeze it. And if you're working at home, I'm just going to work this one quietly. I'm not going to pause the video. Somebody having trouble factoring one of them? There's which one? Oh, no, I'm not having trouble factoring that one.
Wait, did I do it right?
Yeah, the last one I'm having a bit of a tough time with. I'm not sure it's set up correctly. I think I'm going to unfreeze it.
The 5, this one?
All right, so we needed to change that example. It was not set up to be factored. We changed the 60 to a 200, and now we've got it to where I can factor. So two numbers that multiply to negative 40 while adding to negative 6 would be negative 10 and positive 4. All right, so what we do when we get something like this is if we have three things multiplied together, one of them, and they equal 0, one of them has to be equal to 0. So either it's the case that 5 equals 0, which it's not. It could be that x minus 10 equals 0, which would be x equals 10. Or maybe x plus 4 equals 0, which would give us x equals negative 4. So that 5 on the outside is not contributing any solutions. It's just, as we'll see next time, it's just going to make the parabola a little steeper. Okay, so a really common error is when you see anything out in front saying x equals 0 is the solution. So if you just stop to say that either this thing equals 0 or that thing equals 0 or the other thing equals 0, will keep you from making that error because you'll find yourself saying either 5 equals 0 and 5 doesn't equal 0. So it's not going to give you any solution there. All right, here we've got a couple of more, ones that don't have a constant term. So I'm going to start with the one on the right. I'm going to factor this. I'm going to factor out an x. So I'll have an x times x plus 5 equaling 0. And so that means that either x equals 0 from the left, or maybe the thing on the right is equal to 0. All right, so y'all try the one on the left. If you're working at home, try it. I'm going to pause the video. You can check it working fine in a few seconds. Here you go. Remember that we have to start these by setting the equation to 0. You cannot solve these if you don't set them equal to 0. Okay, one thing I forgot to mention earlier is the different names that we use for this. Okay? Really, these are all the same thing. They're solutions to the equation y equals 0. Okay, so we could call them solutions. Okay, they are, maybe you're called roots of the polynomial. Okay, I know y'all like to call them zeros because it really kind of speaks to what they are. We could also call them x-intercepts because if you look on the picture of the graph, that's exactly what they are. They're x-intercepts. And so I just wanted to point out that all of those terms mean the same thing, really. All right, I'm going to do the one on the left for you, and then I'm going to have you do the one on the right. Okay, although they're very similar. Okay, again, so we think, is there a greatest common factor? It's always the first question we ask ourselves when trying to factor something. And this one, there is no greatest common factor. We can't factor out a 2, we can't factor out an x, there's no 4 or 7 in common to everything. So I'm stuck saying, are there any numbers that multiply to negative 8 while adding to positive 7? And there are. I think that would be positive 8 and negative 1, yeah. And then what I do is I take this 7x and I split it up into those 8x's and the negative 1x's. Okay, so plus 8x plus 1x. I leave the negative 2 and the 4x squared the same. And if we're finding the zeros, we're interested in where this thing is equal to 0. Now I'm going to group and factor.
Oh, I wrote that wrong. It should be minus x minus 2, right? Plus 8x minus 1x is 7x. If I had plus 8x plus x, I'd have 9x, and that wouldn't be the same as what I'd written above. So that's plus 2. Okay, there's not really anything in common to the negative x and the negative 2 besides that they're both negative, so I'll factor out a negative 1. And so that'll be negative 1 times x plus 2. Then I'll factor out the x plus 2, and I'll be left with a 4x and a negative 1. And then I've got two things multiplied together equaling 0. I know that one of them has to be 0. So I know that either x plus 2 is equal to 0, or maybe 4x minus 1 equals 0. Okay, for x plus 2 equals 0, I can subtract 2 from both sides and see that x needed to equal negative 2. And for 4x minus 1 equals 0, well, you could look at it a couple ways. I would just add 1 and then divide by 4. So that'll be x equals positive 1/4. All right. Now, looking at that one, I want you all to do the one on the right. If you're watching at home, you can just follow along with my work. All right, and then this one seems to come up all the time. I know it's one that we seem to always see in AP Calculus, and it's one I think of that's got a greatest common factor. So I just want to remind you, when you go to factor, always go to look for a greatest common factor rather than two numbers that multiply to negative 72 and add to negative 6, because it's much easier to just factor out the 6, x squared negative x and negative 2. Much easier to think of two numbers that add to negative 1 and multiply to negative 2. That's going to be negative 2 and positive 1. And remember, at this juncture, we're saying, okay, these three things are multiplying together to equal 0. One of them has to equal 0. Either 6 equals 0, x minus 2 equals 0, or maybe x plus 1 equals 0. Okay, and that gives us x equaling 2 or maybe negative 1. Okay, here's another good one. And it kind of brings up a case that we haven't seen yet. And so what I'm going to do, I'm going to pause the video. If you're watching at home, try this one on your own. See if you can find all the solutions. And then in about 5 or 10 seconds, it's just going to pop up with the answer. Okay, here it is. And this is one of our quadratic equations that has just the one solution. And so that's what we'll see. That's how we'll know there's just going to be one solution. It's when we see the same factor appear twice. Okay, so here we have, maybe we're given the graph of a quadratic equation. And they want us to write an equation for the function in factored form. Well, what we're going to do is we're going to see, okay, the zeros of this thing are at -5 and +3. So f of x, since it's only 1x squared plus bx plus c, we'll learn what to do when that's not 1 next time or the time after. But this is f of x equals x minus 3 times x minus -5. Right? And then if we wanted to find the values of b and c, we would FOIL. Okay, so x minus 3 times x plus 5 is x squared plus 5x minus 3x minus 15. Okay, so this is the same as x squared plus 2x minus 15. Meaning, if we have b is the number of x's, b is 2. And if c is just the constant on the outside, well, c is -15. And I think that's all I got for y'all today.